2.
April 12th, 1981. The sun hasn't yet risen over Cape Canaveral, and the Space Shuttle Columbia is already sitting on its launching pad at the Kennedy Space Center. A decade earlier, large Saturn V rockets were launched and headed for the moon from this very spot. This time they won't be going that far. Just as the astronauts of 20 years ago, Young and Crippen will be satisfied with a few quick orbits around the Earth. They will, however, have to face the risk of being burnt on re-entry. In a way, they'll be reliving Yuri Gagarin's exploits. Ironically, their flight coincides with the 20th anniversary of the first human in space. Young and Crippen, however, are aboard a spaceship which does not bear the slightest resemblance to any of the earlier rockets. Their spacecraft is comprised of a plane attached to 2 missiles and an immense tank. It'll be their job to get this odd-looking object off the ground. The vehicle has never been flown before. For the first time in the history of the conquest of space, a new system is to be tested with a crew aboard. A few minutes before 7 on Sunday morning, this strange machine, which took 10 years to develop and cost $13 billion, is waiting for the moment of truth. Journalists from all around the world are present. The minutes tick away, and the countdown begins. The seconds disappear.
14, 13, T-minus 10, 9, 8, 7, 6, 5, 4. We've gone for main engine start.
There is a flash of blinding light, a blast of deafening sound. The engines ignite. The Earth trembles, and the bizarre machine begins to rise slowly towards the sky, burning 10 tons of fuel per second.
Fast roll program. Go. Roger, roll. Go, booster, go. DNC, go, Eagle, go. Go at 40, Capcom. Columbia, Houston, you're going 40. Columbia, you're going for SRB step.
2 minutes after takeoff, the boosters, having used up their fuel, are cast aside.
Roger, on a step. 103 converge flight at first stage. Columbia, you're looking a little hot. All your calls will be a little
The shuttle's main engines burn for another 7 minutes before they too are empty and another useless tank is released.
you guys did so good, we're going to let you stay up there for a couple of days. Your goal for on orbit.
Finally, the shuttle floats silently in space. 10 years of hard work and effort have finally been rewarded.
Roger, we agree with that.
Once in orbit, the doors of the cargo bay open and expose the radiators which will maintain the spacecraft's internal temperature.
Okay, we want to show you our own spot here. We do
Pictures showed that a few of the thermal tiles were blown off during takeoff. If any more tiles are lost while returning to Earth, the spaceship could easily disintegrate in a matter of minutes during its re-entry.
Looks like a few little triangular shapes that are missing, and we're trying to put that on TV right now.
Roger, Trip, we can see that.
Despite this danger, the astronauts conduct all their scheduled experiments before beginning their descent 2 days later.
The flight so far has gone as smooth as it could possibly go. We've done every test that we're supposed to do, and we're up on the timeline, and the vehicle has just been performing beautifully, much better than anyone ever expected to do on a first flight, and no systems are out of shape. And it's delightful up here in zero gravity, might add. Of course, we owe this to a lot of people, so we certainly want to thank everyone who has helped get this thing airborne. And
Fortunately, the heat shields hold, and the shuttle lands, as scheduled, in California after an entirely successful maiden voyage. January 28, 1986. With a crew of 7, the Space Shuttle Challenger is being prepared for takeoff. It'll be the 25th mission to leave Earth since Columbia's historic flight nearly 5 years earlier. Every detail has been checked. The main engines are ignited. 6 seconds later, the auxiliary rockets are fired, and 2,000 tons of machinery lifts off the ground.
Throttling down now at 94%. Normal throttles for most of the flight, 104%. We'll throttle down to 65% shortly. Engines at 65%, 3 engines running normally, 3 good fuel cells, 3 good APUs. Velocity 2,257 feet per second. Altitude 4.3 nautical miles, downrange distance 3 nautical miles.
After a minute, during a flight where nothing seems to be out of the ordinary, flames appear on the right rocket booster.
Go and throttle up. Roger, go and throttle up.
They spread to the main tank. It explodes, destroying the shuttle and killing its crew.
Altitude 9 nautical miles, downrange distance 7 nautical miles.
In a matter of minutes, the dream has become a nightmare. The space program seems uncertain. Everyone is asking whether the shuttle is viable, whether the risks are too great, and all the years of work have been wasted.
9, 8, 7,
The final Apollo mission in December 1972 marked the end of an era.
1, fire.
There would be no more spectacular voyages in search of new frontiers. It was a time for pragmatism. Exploitation would replace exploration. Unfortunately, every aspect of American space technology had been designed with the expectation of going to the moon. Every piece of fantastic equipment had been built to cover millions of kilometers and was unsuitable for flying in low orbit, just above the Earth's surface. Missions around the Earth in low orbit, however, could still help turn dreams into reality. NASA initiated its post-Apollo operations a few weeks after Neil Armstrong landed on the moon. A flexible spacecraft to transport people and equipment had to be designed if our neighbor in space was to be colonized. Such a shuttle would have to be launched by rockets and would return to Earth like a glider. This new spacecraft would have to be reusable, and it was hoped could return to space after a minimum of maintenance. Such was the challenge NASA's engineers and the American space industry faced. In fact, NASA picked up the spaceplane program where it had been left off in the early 60s. The X-15 plane was an embryo of the space shuttle. Launched from on top of a giant B-52 bomber, this fantastic plane could reach speeds of 7,000 kilometers an hour and an altitude of more than 100 kilometers. The X-15 fell halfway between a conventional airplane and a spacecraft designed to fly in a void. At the time, several small prototypes, like the X-24, were designed along the same lines as the X-15. Such machines help researchers understand certain phenomena, like high-speed gliding. The M2 foreshadowed the shape of the future shuttle. Unfortunately, the development of these rocket planes was abandoned, and the idea of a recoverable space plane was put on the shelf for 10 years. These early studies were revived and eventually led to the final design of the shuttle. The selected spacecraft was shaped like a delta-winged airplane. The forward section of the shuttle is 37 meters long and consists of a pressurized capsule, while the remainder opens into a giant cargo bay. The three main engines are located in the tail assembly and draw fuel from an enormous external tank. Two large boosters provide added thrust to the engines and are dropped after 2 minutes of operation. Six minutes later, once the large tank has used up its fuel reserve, it too is cast aside. Each ensemble is supposed to be reusable 100 times in a 10-year lifespan. The three main engines of the shuttle are extraordinary machines. Although they are compact and only weigh 3 tons each, they produce a thrust of more than 170 tons at takeoff. The development of these engines has been riddled with difficulties. Although no one understands why, the engines exploded when they were first tested. They burn liquid hydrogen and oxygen at very high pressure and are composed of a delicate assembly of pumps and pipes where liquids, when cooled to minus 200 degrees, convert to flames hotter than 3,000 degrees. The boosters on either side of the shuttle also presented some serious problems. In reality, the missiles require solid fuel. Their behavior is so unpredictable that they have never been used for manned spacecraft before. The heat shield was another source of concern for the engineers working on the space shuttle. They considered covering all parts of the shuttle exposed to heat during re-entry with 30,000 heat-resistant tiles. Silicate tiles can withstand very high temperatures, but the engineers had a great deal of trouble attaching them to the shuttle's fuselage. After a 3-year delay, all the problems were solved. NASA inaugurated the spacecraft and began the next phase in the conquest of space. The Columbia Space Shuttle was soon to be joined by the Challenger, Discovery, and Atlantis. Together, they formed a fleet ready to conquer the universe. The shuttle has often been compared to a space truck. From the outset, it was to be a very versatile instrument. The rear cargo bay has room for more than 30 tons of all sorts of equipment. And the forward area can accommodate 7 astronauts while they conduct a wide variety of scientific experiments. The shuttle was used to launch the famous space telescope, which may one day allow us to see the ends of the universe. It can also carry the astronauts responsible for the maintenance and proper functioning of this telescope, which cost nearly $1.5 billion to build. The shuttle can transport and launch satellites from its cargo bay by using a remote manipulator manufactured in Canada. NASA experts also use this robotic arm to retrieve and bring a satellite back to Earth, or to refuel and repair it on the spot. Even if it's only flying a few hundred kilometers above the ground, the shuttle can be used as a launching pad for telecommunication satellites, which must be placed in orbit at altitudes much higher than 36,000 kilometers. But the shuttle wasn't just built for launching satellites. Traditional rockets already do that extremely well. What makes it an exceptional scientific instrument is that it can be converted into a space lab or observation base. It can orbit the Earth in less than 90 minutes at an altitude of 300 kilometers. With its cargo bay, it can carry an array of heavy and powerful remote sensing devices, which can detect the Earth's resources and interpret a multitude of atmospheric phenomena. These features make it an exceptional resource to the military. Whether used to observe enemy defense systems or to position electronic spy satellites, the shuttle is a tool the military are using more often than ever before. In cooperation with NASA, the European Space Agency designed pressurized modules which, when inserted in the shuttle's cargo bay, convert it into a large scientific lab. The behavior of astronauts can be more easily studied in the space lab. As a result, the physiological problems, such as weightlessness, can be more readily understood. Researcher astronauts have been performing experiments in a variety of areas, such as health, metallurgy, electronics, and the production of new medication and materials unknown on Earth. The Space Shuttle system is as ambitious as anyone can expect when spending more than $10 billion. Unfortunately, this technology has neither proved itself nor silenced its critics. The tragic explosion of the Challenger in January 1986 delivered a severe blow to the shuttle system's credibility. The accident was a serious setback to a program already plagued by numerous unpredictable problems. The shuttle remains a complex and costly method of space travel. With every mission, however, it becomes more and more economical to use the same launching vehicle, as has been demonstrated by the American Space Shuttle program. All major space powers are now developing reusable spacecraft. The Europeans are working on the Hermes project, a reusable capsule launched by a new generation Ariane rocket. This little shuttle will be much lighter than its American counterpart. Its primary purpose will be to carry astronauts, not heavy equipment. Although their experiments are clouded in secrecy, the Soviets are also developing a reusable spacecraft which could one day replace the system of launchers and capsules they've been using for almost 20 years. A mini shuttle was photographed while being recovered after an experimental flight. Some analysts claim, however, that the Soviets are also working on a giant and even more powerful shuttle than the American one. Shuttles will probably make their most dramatic contribution to space development as space trucks. They are required for the transportation and assembly of the components of future permanent space stations, which the space superpowers hope to have built by the mid-1990s. Engineers have already begun to look for quicker and more efficient assembly techniques. No doubt, numerous other missions will be necessary before the basis for such stations is laid.
De wereld wordt één groot dorp. En over een week zie je hoe de ruimtevaart daaraan meewerkt.